In this lesson, we are going to cover design intent. Design intent is how your model behaves when the dimensions are modified. Now, the part we have on the screen will allow us to demonstrate a very simple example of design intent. Let's say, for example, we want to create a hole in this top face, and we always want this hole centered. Now, we're going to step through this without taking design intent into consideration. So let's begin. First, we need to look at the size of that top face. It's 80 millimeters by 100. So that top face is 80 by 100. So let's start a new extruded cut feature. We'll select the top face for our sketch and then create a sketch circle. We'll dimension the circle to a diameter of 25. And then we'll locate the circle from each edge half the distance of the size of the face. So the face is 100 in this distance. 1/2 of that is 50. And then 1/2 of 80 is 40. I'll close out of the sketch. And let's cut this hole all the way through the part. So we'll select through all and then close out of the cut extrude feature. Let's place this back into an isometric view. And you see the 25 millimeter diameter hole is centered within the 100 by 80 millimeter face. Now let's say, for example, at a later time, you decide to change the depth of this extrusion to 150. Is that hole going to stay centered? Well, let's try it. I am going to edit the Boss Extrude 1 and change the distance to 150. I'll close out of the extrude and notice the hole is not centered. And that's because we did not take design intent into consideration when we added this feature. If we knew there was a chance the depth of this part was going to change at a later time, we should have taken a different approach with locating that feature. So let's redo this and correct the problem. I am going to edit the sketch 2. I'll view normal to it. And then I will delete the 2 location dimensions. Instead, I am going to add a construction line from corner to corner. I'll select the midpoint of the construction line and then the center point of the sketch circle and apply a relation of coincident. I'll close out of the property manager, exit the sketch. Once again, the hole is centered. Now if I go back and change the depth of the extrusion, you will see the hole remains centered. Now that's a simple example of design intent. No matter what depth I change this to, this hole will always be centered because we added a geometric relation between a construction line running from corner to corner and the center point of the circle. Let's take a look at another example. On this example here, we see the part is symmetrical. In fact, it's symmetrical about the front plane. Now, knowing the part's symmetrical, when we go to extrude the part, it would make sense to extrude the sketch about a midplane. That's another simple example of design intent. Let's take a look at an example which is a little more complex. Let's edit the sketch for this back flange and then view normal to it. You'll see that we have a hole size diameter 0.25. However, we don't have a dimension on these 3 holes. That's because we added a relation of equal. So if this one hole size changes, the other 3 holes will update with it. Let's give it a try. 0.375, and notice all hole sizes update. I'm going to go ahead and close out of this sketch. And now let's edit this front flange. We'll edit the sketch. And once again, notice this is a symmetrical flange. This radius is repeated on the other 3 sides. Once again, notice we do not have each one of these radiuses dimension. That's because we applied an equal relationship. So if we change the size of this radius, The other radiuses will update with it. So in closing, design intent should always be something considered when you create any model. You want to consider how the part is going to be changed or modified down the road, and try to design that into your model. Capturing design intent in your model will save you a lot of time down the road.